Okay, after type of frictions, the next topic is angle of friction. Angle of friction simply means this is a flat surface. Over this flat surface, I substituted okay. See, what is angle of friction? Angle of friction is if I place this body on the rough surface, this rough surface will exert a normally action over the body and a frictional force will act on the body. If the tendency of body is to move to the right hand side, then friction will act to the left hand side. Sorry. This resultant of friction and normal reaction this is the resultant of normal reaction and frictional force. The angle with this normal reaction makes with this resultant is represented by theta, and this is what we call angle of friction. So angle of friction it is the angle between normally action and resultant of friction and normal reaction. Now, if I name this triangle as like, I say this is point O, this is point A, this is B, and this is C. In this triangle, we can calculate tan theta. This is perpendicular over base, which means this is AB over A. AB, this side AB is parallel to frictional force, so this is F. And this limiting friction, body is at rest, so the friction is limiting. Divided by AO. AO is normal reaction. You can write your force of limiting friction as this is mu L into N divided by N. This N will cancel this N and you will get that tan theta is mu. So this is the use of angle of friction. If you have angle of friction, then tangent of angle of friction will give you coefficient of friction. So we could use this in numericals, like if you have like angle of friction for rough surface is 30 degree. Calculate coefficient of limiting friction. So coefficient of limiting friction is tangent of angle of friction, which is 1/3. So this is mu L, which is tan 30, which is 1/3. Okay, after angle of friction, the next is angle of sliding or angle of repose. For angle of sliding or repose, let's say this is an inclined plane. Angle of inclination is alpha. I placed a body of mass m here. So this angle alpha is the minimum angle at which the body placed on it starts sliding down. So let's say this plane is flat. I placed a body here. So body is not sliding. I'm just inclining this plane. Then at a minimum inclination, this body starts sliding. So the minimum inclination of a plane with horizontal at which body just slide down is known as angle of sliding or angle of repose. So this is minimum angle of inclination So the minimum angle of inclination at which body just slides down is known as angle of sliding or angle of repose. So up to angle of repose, body is in equilibrium. Let's say if I say that for a rough surface, angle of repose is 20 degree. That means your body is at rest up to 20 degree. If you increase your angle just a little bit, then 20 degree, like if your angle is 20.001, then body starts sliding down. I'm repeating again. Up to angle of repose or angle of sliding, your body is in equilibrium. If you increase your angle even by a small amount, then angle of repose or angle of sliding, then body starts just sliding. Let's say angle of sliding or repose for a plane is say 20 degree. If you make an angle 20.001, then two body will start sliding. So the various forces acting on the body are mg is acting in downwards direction. This angle is alpha. This is mg cos alpha. It's mg sin alpha. This is the normally action. So mg sin alpha is acting in downwards direction. So friction will act in upwards direction. The direction of friction is always opposite to the tendency of motion. If the tendency of motion of a body is to slide downwards, friction will act in upwards direction. So in equilibrium, both the forces will balance each other. FL will try to balance mg sin alpha. First equation. And this normally action will balance this mg cos alpha. Normally action is acting perpendicular to the inclined plane in upwards direction, and this is acting perpendicular to the inclined plane in downwards direction. So both these forces will balance each other. Now the formula of friction is mu L into N. That is equation number 3. N you can substitute from equation number 2. So I can substitute 2 in 3. When I substitute 2 in 3, I get force of limiting friction is mu L into mg cos alpha. Yes, Sania. It's mu L into mg cos alpha. So see, on inclined plane, friction is not mu mg. Frictional force is mu L mg cos alpha. That's why I'm stressing to remember this formula of friction. That's mu L into normal reaction. In few texts, you may find that friction is mu mg. But this formula is true only for a flat plane. For inclined plane, now you'll remember another formula. But instead of remembering this mu mg, always remember that friction is coefficient of friction multiplied by normal reaction. Just multiply your coefficient of friction with normal reaction. Next, you can do one thing. You can equate 1 and 4. Now, if you equate 1 and 4, you will get mu L mg cos alpha is mg sin alpha. So mg will cancel this mg. Sin alpha by cos alpha, which is tan alpha basically. So this is another important result, that if you have angle of repose or angle of sliding, then coefficient of friction is tangent of angle of repose or angle of sliding here. For example, for an inclined plane, angle of repose is, say, it's 45 degree, not 45 degree. Let's say 30 degree. Calculate coefficient of friction. Coefficient of friction is mu L tan 30, which is 1 by root 3. So this is how you can calculate. So this is how we calculate friction over an inclined plane. So if you have an inclined plane, then friction is coefficient of friction multiplied by normal reaction. Okay. After this inclined plane, the next thing is, so that was about friction. Let's say this is an inclined plane. Angle of inclination is 30 degree. I placed a body of 10 kg here. Coefficient of limiting friction is 0.2. Calculate acceleration of body down the inclined plane. Body is moving down the inclined plane. Calculate its acceleration. This is 10 kg. So here is the weight acting, which is 10g. If this is 30 degree, then this is 30 degree. This is 10g cos 30, and this is 10g sin 30. This is the normal reaction. The tendency of the body is to slide downwards, so friction will act in upwards direction. Now, since coefficient of kinetic friction is not given, so you can assume that coefficient of limiting friction is equal to coefficient of kinetic friction, which is 0. A normal reaction balance the cost component of weight. You can write your normal reaction is 10 g cos 30. Cos 30 is root 3 by 2. It gets cancelled out. Normally action is 50 root 3 Newton. After normally action, you can calculate force of livatic friction or force of kinetic friction, which is equal to mu n. Mu is 0.2, 50 root 3. Force of limiting friction and force of kinetic friction, they are equal. It comes out to be root 3. Next, calculate the value of this 10 g sine 30. 10 into 10 sine 30 is half. So that's 50 Newton. So if I look at this inclined plane, then over this inclined plane, this body of 10 kg is placed. Force of 50 Newton is acting down the plane, and a frictional force of root 3 Newton is acting up the plane. And it's obviously this force is greater. So it will definitely move in the downwards direction with certain acceleration. Next, you can write this equation as 50 minus root 3 is 10a. So you can write like 50 minus root 3 by 10 is equal to a. So the acceleration is 5 minus root 3 by 10 meter per second. Okay, after this, the next is frame of reference. See, what is frame of reference? Frame of reference is basically place of observation. So the place from which you are taking observations is frame of reference. Frame of reference is nothing but place of observation. You can divide your frame of reference into two categories. It could be either inertial frame of reference, or your frame could be non-inertial. Inertial frame or non-inertial frame. See what the difference between inertial and non-inertial frames. Inertial are those frames which are either at rest with respect to Earth or they are moving with constant velocity. Inertial means frames at rest with respect to Earth or moving with uniform velocity with respect to Earth. So these types of frames are known as inertial frames. For example, a car which is at rest with respect to Earth, this is an inertial frame. Or a car which is moving in a particular direction with a velocity. Car which is moving in particular direction with a constant velocity is also an inertial frame. So this is the definition of inertial frame. Frame is either at rest or they are moving with constant velocity. These are examples of inertial frames. So in inertial frames, Newton's laws are valid. The Newton's first law, the law of inertia that we did, is valid in inertial frame. particularly first law. All laws are valid, but the law of concern here is first law. What does first law say, Sania? What is Newton's first law? Sania Fatma, what is first law? So the first law says a body cannot change its state unless external force act on the body. That's first law. Okay, Sania, no issues. The first law says the body cannot change its state unless some external forces act on the body. That's Newton's first law, basically. When we say non-inertial frame, non-inertial frames means frames accelerating or rotating with respect to Earth. These frames are known as non-inertial frames. For example, if I take a car and it's moving with a continuously increasing velocity, that means car is accelerating. This is an example of non-inertial frame. Or if you have a sphere which is rotating about its axis, it's again an example of non-inertial frame. So these are non-inertial frames, an accelerating car or a rotating body. You can't use Newton's laws in non-inertial frames. Newton's laws are not valid in non-inertial frames. That's a limitation of Newton's laws. You can say it's sort of limitation of Newton's laws. You cannot use Newton's laws in non-inertial frames. See, example, how Newton's first law is not valid for a non-inertial frame. Always remember that Newton's first law says a body will not change its state unless an external force acts on the body. And for force, you need an agency which is applying force. If a body is at rest and you didn't apply any force on the body, then body will not move, it will remain at rest. If a body is moving in a certain direction with a certain velocity, unless you apply an external force, the velocity of body will not change. So if I take a block, let's say it's a box or a car or something, let's say this is a bus. This bus was initially at rest. This is this passenger standing in the bus. As soon as the driver of the bus switched on the engine, the bus starts accelerating in this direction. As soon as the bus starts, this passenger standing in the bus will experience a backward force. But if you examine carefully, you will not find any agency which is applying this force. Let's check what different agencies we have. We have the engine. The engine is applied force in the forward direction, not in the backward direction. So engine cannot apply this force. The next agency is the floor. The floor can apply force in the upwards direction, which is normally action. But the floor cannot push this man in the backward direction. The next agency is Earth. Earth can pull this man in the downwards direction, not in the leftwards direction. So this man is experiencing a force. Basically, he's moving, but without any actual force. This man moves in the backward direction, means it accelerate in the backward direction, but without any force. You won't find any force which is acting on the man. This violates Newton's first law. Newton's first law says if a body accelerates in a direction, if it changes its state, then some external force is responsible. I'm repeating the whole thing again. Newton's first law says a body cannot change its state unless an external force acts on the body. This is Newton's first law. This first law works very well for the inertial frame. But as soon as you come to a non-inertial frame, then this Newton's first law is not valid. This example will clear this thing that Newton's first law is not valid for non-inertial frame. I take a bus. This passenger is standing in the bus. This bus starts accelerating in the forward direction. As soon as the driver of the bus starts the engine and bus starts accelerating in the forward direction, this man standing in the bus will experience a push in the backward direction. He move in the backward direction. So we have, if man moves in the backward direction, then there should be some force. If Newton's first law is correct, then there should be a force which force this man to move in the backward direction. One by one, we will take all possible agencies which can exert force in the backward direction. The first one is engine. Engine will exert force in the forward direction only, not on the backward direction on man. Then this is this floor of the bus. It can exert force in the upwards direction only, not in the backward direction. Then this is earth. Earth will exert force on the man in the downwards direction only, not in the backward direction. So you will not find any agency which is exerting force over the man due to which he is moving backwards. So apparently this man is moving in the backward direction without any force. So the next point says to use Newton's laws in non-inertial frame. We use concept of pseudo force. Just note it down, then we'll see what is pseudo force basically. What do we mean by pseudo force? So pseudo means not a real force, a virtual force. Virtual force that acts on body in non-inertial frame so that we can use Newton's laws in non-inertial frame. Next, let's see how to calculate this pseudo force. Let's say this is a frame. This is some bus or truck. It's moving in the right hand side direction with some acceleration in. Over this truck, I place this body of mass. Now, since this truck is accelerating, that means this body is placed in a non-inertial frame. So as soon as this truck accelerates in the forward direction, this body slowly move in the backward direction, slowly keep on moving in the backward direction. So if this truck accelerates in the forward direction, this body keeps on moving in the backward direction. This body will basically experience a pseudo force in the backward direction. And that pseudo force is mass of body multiplied by the acceleration of the system. This is the pseudo force acting on the body. So the pseudo force, the formula for pseudo force is its mass of body multiplied by acceleration of frame, not acceleration of body. We'll take the acceleration of frame, which is moving in the right hand side direction. To make this thing very clear, let's take a truck. This truck is accelerating with 2 meters per second square. This is this body of mass 10 kg placed on the truck. The coefficient of friction between the truck and the table is 0.2. Body of mass 10 kg is placed on truck. Accelerating at 2 meters per second square. Calculate first part. Pseudo force on body. Frictional force on the body. Third, acceleration. So solution of the first part is the pseudo force is basically mass of body multiplied by acceleration of frame. So here mass of body is 10 kg. Acceleration of frame is this 2 meters per second square. So that's 10 into 2, which is 20 Newton. After pseudo force, the next thing is you need frictional force on the body. So see, frictional force is mu n. Okay, if in the coefficient of friction, it's not given whether this is limiting or kinetic. That means both limiting and kinetic are equal in this case. So F is equal to mu n. So your mu is 0.2. And normally action, the weight is 10 g. This is normally action, and you know this normally action is 10 into 10, which is 100 Newton. 0.2 into 100, which is 20 Newton. So this body is experiencing a force of, the pseudo force which is acting on the body is 20 Newton. And the frictional force on the body which is again 20 Newton. Now, can you guess what should be the acceleration of the body? Yes, Noor, can you guess the acceleration now? Yeah, it should be zero now. Both the forces are equal and opposite. So the net force acting on the body, so acceleration of the body is zero. The net force acting on the body is zero. So acceleration of the body is zero. So this is how we solve problems on pseudo force along with friction.